Welcome everybody, and thank you for joining the first installment of our new GeoMagic Control-X Product Spotlight series. This webinar is focused on the deviation location functionality in GeoMagic Control-X. I appreciate you joining us today, and I hope you'll be able to join us again on future Product Spotlight webinars. A few housekeeping items before we get started. As you may have noticed, all attendees' lines were muted upon joining the webinar. Therefore, please use the Q&A button on your screen to submit any questions as we go along. In an effort to abide by our 20-minute time allotment, we may not have time to address all questions live during the webinar. If that is the case, we will follow up with you after the webinar with an answer to your question. Additionally, we will make the answers to all frequently asked questions available for all of you who have attended. Finally, in a couple of days, you'll be receiving a follow-up email with a link to view the recording of this webinar, as well as a copy of the file that is used for today's demonstration. Once again, thank you for joining us today, and I will now pass it on to Adam Waraksa, a GeoMagic application engineer, as he is leading today's demonstration. Adam, it's all yours.
Thanks, Adam. Okay, so today we're going to talk about deviation location, which is a function in Control-X. It's a canned little feature that allows us to go in and automatically analyze things based on scan data only. So one of the so what does it allow us to do? We have our scan data, and that allows us to come in and check out areas of interest on a part and what the deviations look like. So we can classify these things, and we don't have to go in and hunt and peck over what the object is and what the placement is and try to fit features to it, or even just manually highlight triangles. So we'll pick an area of interest, and then we'll let the tool do the rest. What are some of the applications for this? So a couple of applications, you just saw a picture of an aircraft skin there, deviations and of armor, reactants, stuff like that. Molded parts, sometimes you have some sink marks in a mold and things like that that you'd like to check out and see if they're within spec, like cavitation functions on a propeller, stuff in the auto body and body in whites in auto body. We could also do things with long-range topology, if you'd like, looking for dense craters and things like that. Turbine blade damage, often you're looking for dents and deviations on leading edges of blades and things like that, seeing where they may have taken some heat. We can also use it for corrosion analysis, whether it's pipe or valve or something like that. We can really quantify the pitting and the amount of area that's lost. And then again, just some other auto body type stuff that we can do. Sometimes you're looking to classify something, whether it is a more of like a paintless dent removal, or maybe you'll need to send it to a real body shop. So just a couple quick applications there. So how do we use it? Well, we just bring in some scan data. We can specify any sort of reference coordinate system that we would like to use to base our measurements on for positional placement of where the deviations are. And you basically just want to document deviations. That's why you would use it. So let's jump right into CX here. And you can see I have a aircraft wing loaded here. It took some heat during a hailstorm, and it actually needs to get checked out. So what we're going to do is we're going to use this predefined coordinate marker here down on the bottom to base where our dimensions are off of. We sort of need this just to locate where things are in space on the section that we're going to make, and base it back to the overall part. There are we could put this wherever we like it. This one was actually predefined for us per our client. So, and then what we're going to do is just select the measurement area. So we're actually on a tessellated triangular mesh now, and I'm just going to look at it here and see. Looks like we have something up over in here of interest too. So I'm just going to use our polyline selection tool, and I'm going to come in here and just select the surface that I'm interested in taking a look at. Once I do that, I'm just going to hit apply, and the function itself is going to just pull that piece of mesh out. hide the rest of the part so we can see what we have here. Now what the CX is actually going to do is it's going to create a surface to fit the overall contour of the part, and then we can use that surface that's ideal and smooth to tell where the deviations are going to be. And then there's a bunch of different ways we can manually specify what that surface is. But I'm just going to use a little automatic function today. So there's a couple things we can control in here. We control how many points make up that patchwork of essentially that NURBS surface that it's going to make. The more points that we have, the more accurately we can fit the surface. But for smooth sections, stuff that's smoother, using fewer points is always nicer. Just creates a nice smoother surface. We can actually control the search scope and the deformation removal too. Search scope relates to how much past this area on the part it's going to look to fit geometry to this surface. And the deformation removal is if we had some undulations in the surface, we could basically turn this up to get rid of some of that undulating data. So maybe we had like some creases between panels or something like that that we don't really want to take into consideration. So we could bump that up some if we want. But this is a pretty good smooth area the way it is. So I'm just going to hit OK. You'll notice what CX is going to do now. It's going to go in and look at all of the mesh, and it's going to calculate a surface based on that. So now that it's done that, my little bar here, make it a little bigger. We can check the surface, see how it looks. So it is a nice smooth curved contour encompassing our part. And I can click on deviation here. Automatically we get a color map of the deviation fitting the surface. And we can change stuff like tolerancing on the color bar and things like that. This is a pretty large section of a part here, about 30 inches probably. And, the green bar right now is essentially 40 thousandths. So, or 4 thousandths, I should say. So we're looking pretty good here as far as fitting on that object. So we're going to move over to the next stage if we're happy with that. And you'll see automatically it went in and highlighted all the area of interest of deviation. And it basically gave us a starting point for what our extraction depth is. So extraction depth is looking at that surface and anything below. We can also do height. So maybe you have some stuff coming out of the surface that you'd like to check. So we can do the exact same thing with height. We could actually do both at the same time. It really depends on your application. So right now we're saying that everything that's basically 20 thou or deeper is being outlined. Maybe we want to increase that a little bit more. Maybe we want to say, hey, let's go up to something like a little more reasonable. We'll do something like 50 thou. And make sure to see, like, if anything's further down than that, that'll be our things of interest. So you see automatically it got rid of a couple things that were very shallow on the surface here. And it highlighted everything else, gave them a nice little tag here, just to let us know what it's doing. Now, besides that, we found these objects, but what we're really going to do is we want to maybe classify things down a little bit more. So we have a deviation threshold and area. Maybe you have a certain square area of an item that you're looking for that you would want to, be suspect for repair, or really qualify something for rework. So you could select either one of those. I'm actually just going to use deviation threshold and say we're going to look at stuff that is of a certain depth overall that's going to flag an item for us to investigate in person, essentially. So let's do this, and I'm just going to make this like minus 0.1. So we'll do essentially a 1/8 inch here. So we can check that out. So now you'll see what we're left with is 2 objects that are tagged, and everything else is still there. All those things are still created in the background, but these are our 2 objects that we're actually meeting our criteria for needing personal further investigation. So what I'm going to do with those is move to our next step. In the next step is where we're actually going to start laying our measurements on. So right now we have no objects selected, so let me select these 2 objects that are here that we're going to check out. And then let me, if I want to, I can throw a proximity dimension on just sort of like right away. Maybe if they're a certain distance apart, they'll be okay. But maybe if, you have stuff in aircraft where things are close enough together, they need to get fixed. If they're further apart, maybe they don't. So that just gives us an overall measurement on that. We can actually still insert a color map on the surface here so we can see our overall part, where things are located. And maybe instead of just doing that proximity dimension and some other stuff like that, maybe we could go into the dimension datum style if we want a little bit more information. So let's go into dimension datum style here. A couple different things we can do. So this max deviation and distance to datum. So these measurements will relate back to where our coordinate system was based. So you can see that they're measuring from back where our coordinate system was, so we can classify things there, the distance of where those objects are based on that, and it's measuring to essentially at the deepest point, like center of mass of where that deviation is. If that isn't really of interest to us, we could always say maybe we just want the length and width of the objects. Maybe a certain size is something we want to flag, so we could pull tags out to specify that stuff. We can still throw that minimum distance on if we want to between the objects. And we can really just set up whatever we like going to it. So we can just do distances in X and Y based on our coordinate system if we want to. We can change the color map tolerancing if we needed to. We could say, if we wanted to try to flag things in certain colors that were certain depth, we could do that. We could also just show color maps on objects if we wanted to really zoom in on something. We could also show like contour curves of the distances surrounding the object as they dive in. And you can see that our min and max range here is probably a little too low for these. So let's turn this up. We'll just make these I'll make this a quarter here. And we'll make this one minus quarter. Having typing issues, apparently. And then we can see our contour lines better on our part and like what's going on with our stuff here if we wanted to do that as an investigation. But let's go back to our color map on our surface here. We can zoom out. And that's essentially one of just the quick ways of using the tool to grab some locations of things. If I want to, I can actually just like update how I want stuff to look in a report and hit OK. Now we're back to our overall wing section here. What it looks like, where the deviations, we could have listed where the deviations are in 3D space. We have the stuff listed right now for the length and width of the objects. You'll notice over in the feature tree, all those things that we don't have shown, they're still created in the background. So you could always come in and turn all these things on and off however you'd like to create different views and different displays. So it's just really convenient to come in and edit all that stuff. You'll notice when we're in the function, all of this stuff is also down in our tabular view right away. So as we're looking at things, you can automatically just see area and volume of that type of stuff, the positional data and things like that. And this is all the stuff that would essentially be reported on. So let's go in and generate a report quick. If we generate a report, I'm just going to grab essentially one of our blank templates here. We don't have any reference data in, so I'm going to pull that out. And I'm actually just going to do our pictures of our measured data and the location of deviation. One of the cool things about the reporting is if I do a 3DF page on the report, this stuff will come in and you will be able to open that in Acrobat, spin it around, look at the color map, see the part, and then the functionality is in the Acrobat document of the PDF where you can actually turn the tags off and on and things like that too. So that's really great to be able to send someone for they need to check out some analysis, or you're just sharing something even internally. They don't have access to the program. So we just hit generate here, and it's just going to open our little layout editor here. You can see I left everything blank. We have pictures of our standard views of the part, the DV location shot that we took here of the size of the objects and where they are, and then the tabular data showing us those objects with the maximum depth, the area, the volume, positional measurements on those devices. And that is essentially the deviation location tool in CX. So kept that Short and sweet for you guys. Is there, so I'd like to point out a couple other things here. So just for some other resources, I would say to come in and definitely check out our website. You can always hit up our guys for sales and pricings. Gettingstarted.geomagic.com is sort of your one-stop shop for finding everything, including help files, videos, like walkthroughs of different products and things like that. And I would say definitely hit that up also. And I guess, Adam, we'll go back to you and take some questions as they've come in.
As we wait, though, I'll go ahead and give a brief closing here. So this does bring us to the end of our GeoMagic Product Spotlight webinar on deviation location. So, and please be on the lookout for invitations for future Control-X product spotlights from 3D Systems. In the coming days, as I mentioned earlier, each of you will receive an email with a link to the recorded version of this webinar, as well as some useful links regarding Control-X and answers to any frequently asked questions. We did just have a question come in. So Adam, we've got a question here. Can the green on the color map have gradients? All right. Well, fantastic. Well, thanks again, everybody, for joining us today. That does bring us to the end of the questions that have come in at this point. So if any other questions come in, please feel free to go to our website and request those, and we'll be happy to follow up as quickly as we can. So thank you, everybody, once again for joining us, and have a good rest of your day.